So hopefully it makes sense now when I say this. E's the limit as n goes to infinity of 1 plus 1 over n raised to the n. That makes sense? I mean, we're letting n get bigger and bigger, and we're letting it get 10 times as big every time, so already at 1 billion, that's really big. But it can get way bigger than that. That's just 10 to the 9th power. Okay? What if we went up to 10 to the 10 billionth power? 10 billion steps, just like these. Okay, this number would get really long, right? It'd be unchanging past a certain point, and that point would be way out there, okay? But there's no limit to how far out that can go. So, E is this.
What's that, H? H to the?
No, N.
Oh, N, all right.
Okay, we're letting N, this number N here, we're letting this number approach infinity, okay? And that's what E is. In the limit, as we go on, it's the number that these numbers approach as a limiting value. You can see that we're approaching something close to 2.718281828. We can already see that, right? Okay? Now if you continue this process where you're doing enough decimal places to show the change, you're just going to keep moving to the right and it never ends. Okay? In the limit, if you could keep this up forever, and you can't, well, that limit is what E is. Okay? And then we can say this. Well, for a bigger N, you get a shorter compounding period. N equals 2 is semi-annual. That's every 6 months, right? N equals 12 is monthly. N equals 52 is weekly.
Sometimes n equals 50 is weekly because they.
N equals 360 is daily.
Not 365?
Nope. Sorry, banks won't do that.
They do that with n equals 50 for weekly too. Sometimes they
Do
take
they
away
use
that
50?
2 weeks. Yeah.
Yeah, there's not much weekly compounding. So really I didn't know what the convention was. I suspected maybe, but I wrote 52 because that's not too hard to deal with, okay? So, I mean, if you want to be technical, it's closer to 365 and a quarter, isn't it?
Mm-hmm.
Yeah.
Or 365.27 something, I think, I don't remember. Okay? So, that's daily, so we could go n equals some number every second. How would you figure that number out? Figure out how many seconds there are in a year. 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and 360 or 65, whatever, days in a year, right? And then we could go 1,000,000 times that many times and get every microsecond,
Let's not do that.
every nanosecond. Well, as n goes to infinity, we approach
E.
continuous interest where the time period approaches 0. So every instant we're compounding, okay? And when we do that, if we let n approach infinity, then this 1 plus 1 over n to the n becomes e, right?
Yeah.
So we get e to the t, okay? Or actually, should be p naught e to the t. So let me write out the principal function.
E to the T.
Okay?
Equals absolute, P absolute, E to the T.
Looks like I got 3 dots there, but they're smudges on the board that just have to look that way. Okay? So that's where we get this exponential function. That's one way we can understand the exponential function. Now, if we have compounded at interest rate r,
It says hold.
compounded continuously, I could work out the algebra, and I might at some point, but probably not. Because if I do it in a pre-calculus class, almost nobody follows it, although some of you would, okay? I don't want to waste everybody's time. If anybody really wants to see it, just ask me, and I'll throw in a little short blurb as a supplemental video, and I'll do that for you. Email me and ask for it, and I'll do it. Ask me in person, I'll forget. Okay? But I'm glad to do it if anybody wants to see it. Anyhow, you get P naught e to the RT. Now that's because if your interest rate is R, it's 1 plus R over N, isn't it? 1 plus R over N to the NT. And then you do this thing called a change of variable, which is a tricky algebraic thing that we really don't have time to talk about, since it'll go over most people's heads and you don't really need it in this course. Good thing to know. I wish we could do it, but we can't. But with a little change of variable, we get this. That R ends up kind of in this exponent. Okay?